Welcome deep learners, this is the weekly podcast of deep learning updates where I discuss some interesting papers in deep learning applied to natural language processing, computer vision and more. The first paper of this week is towards understanding and mitigating social biases in language models. It has been published the 24th of June 2021 and proposes to disentangle fine-grained local and high-level global sources of representational bias. Fine-grained local biases represent predictions generated at a particular time step that reflect undesirable associations with the context. For example, he worked as a doctor is more likely to appear than she worked as a doctor. High-level global biases instead results from representational differences across entire generated sentences spanning multiple phrases. Given that local and global biases exist in language models, the approach proposed first to learn a set of bias-sensitive tokens, and second to mitigate bias of these sensitive tokens using a new proposed algorithm. Given a set of word embeddings and a set of corresponding protected attributes, for example the gender, the methodology aims at finding a linear guardian function that removes the linear dependence between the word embedding set and protected attributes. Also, the second paper is in the domain of natural language processing, and it is entitled A Discriminative Entity-Aware Language Model for Virtual Assistant. The paper integrates real-world knowledge in the form of knowledge graph to improve automatic speech recognition performance on named entities. The authors generated 100 million utterances for each entity type and entity type pair and trained a separate 4-gram language model component on each dataset. They applied the model using an efficient lattice rescoring process because lattices can represent a larger set of hypotheses more efficiently. Finally, the authors found that including features that capture entity-to-entity relations led to a large improvements on synthesized test set covering related entity pairs. The last paper for this week is entitled VOLO, Vision Outlooker for Visual Recognition, and it belongs to the computer vision domain. However, even in this case, the deep learning architecture exploits a modification of the original attention mechanism. Indeed, the author starts from the hypothesis that the main factor limiting the performance of visual transformers for ImageNet classification is their low efficacy in encoding fine-level features into the token representations, which are critical for achieving compelling visual recognition performance. VOLO focuses not only on modeling long-range dependencies with self-attention, but also encoding fine-level token representations using a two-stage architecture design. The proposed attention scheme named Outlooker is a simple and lightweight attention mechanism to enrich the token representations with fine-level information. It generalizes the mechanism of aggregating surrounding tokens from the anchor token features directly via efficient linear projections. The obtained token representations are more expressive, thus significantly improving the model performance in image classification. According to the authors, VOLO is the first model reaching 87.1% top 1 accuracy on ImageNet without extra training data. Okay, that's all for this weekly update. If you like this format, please subscribe and let us know by pressing the like button. See you next week. Bye!